So we can see that head move from one end to the other end, services request along the way. However, it does not serve a reverse trip and go to the beginning directly as if it is circular queue. Here we have to start from 53 and then we have to serve a request in one direction like 65, 67, 98, 122, 124, 183. It is going to serve in one direction, and after reaching to the last point, it will directly move to the beginning of the particular uh, head direction. So the beginning request is 14, it is going to serve, and then 37 it is going to serve. So in between from trip from 83 to 183 to 14, it is not going to solve anything. Once it will reach to the starting point, it will serve the other request. In some example, we have serviced up to 199 and then reached up to 0, and then it is going to serve to the next points. So in these two ways we can calculate this example. Total head movement we got here is 153. Next is multi-level queue scheduling. Now, what is multi-level queue scheduling? We have gone through the other scheduling methods. This multi-level queue scheduling belongs to the process scheduling, like other process schedulings. We are having lots of processes, and CPU has to schedule these processes one by one. This process will go into the ready queue. What we were doing up till now? We are having a ready queue like this, and in this ready queue, we are going to serve all the requests P1, P2, P3, whatever processes we are having, we are putting in this ready queue, and it is going to serve by the CPU as per FCFS, SJF, priority, round robin like this. But in multi-queue scheduling, we are having more than one queue. Here we are having different queue for different processes. We are having some system processes, like we are having some interactive processes like Microsoft Word with which we are going to interact. We are having some batch processes. There is no interaction is required. Once the one batch will complete, we have to get the output and then next batch will go. So there is, we can say, no need of interaction. So there are various processes which is having different priorities. So all these kind of different processes, we are having different queue. We can see in this figure, for bike we are having different parking place, for car we are having different parking place. Same way, but the system has a fixed queue. System can't swap from one queue to another queue. Like in this queue, the systems are following round robin method. Here it is going to follow, we can say, FCFS. Here it is going to follow some priority based method. So once the processes of this queue, like I'm having four processes, P1, P2, P3, P4, it is not going to finish. The next processes will not going to start their execution. So that processes has to wait until CPU will solve this process of this particular queue. So this will sometime occurs a starvation. So what is the solution? Solution of this problem is multi-level feedback queue scheduling. Here a processes can swap from one queue to another queue. Like here we are having processes 1, 2, 3, 4. Here 5, 6, 7. Here 8, 9, 10. The process number 10 will get done very late. So this process number 10, I have to swap at Q2. So once P1, P2, P3, P4, P5, P6, P7, we can say will going to complete its execution. This Q3 will not going to get the turn. So if I'm writing like this, I'm having process 1, 2, 3, and 4. Here I am having process 5, 6, and 7. So until this 4 process will not complete, this will not going to get the turn. Here I am having process 8 and process 9. Okay. Now I'll shift this process number 8 here. So again this 4 process will finish, then this process will going to get the turn. then 5 6 7 will finish, then this 8 will going to get the done. So we can move process from higher priority to lower priority, and we can move process from lower priority to higher priority. So this is called multi-level feedback scheduling. Last topic is system call. We are having two modes. The first one is user mode and the second one is kernel mode. What is the difference between the user process mode or the kernel processes or the kernel mode? Suppose I am giving 2 plus 2, right? So that is done under the user instruction, that is done by the user input 2 plus 2. But the process and the output can be sent by the kernel. So whatever user wants to do, user has to send some instruction to the kernel, and this instruction is known as a system call. So whenever user requires any resources from the kernel, at that time user has to send a system call. There are various type of system calls like process, for file, for device, for information, for communication. The process system call is related with the process creation, process termination. File management is for reading, writing, executing the file. Device management is for manipulation, reading and writing of the devices. Information is for transferring some information between the user program and the system program. Communication is for interprocess communication. Suppose user wants to change the, we can say some permission of the file. In that case, user has to give the system call like chmod. We have already learned this during the Linux lab. Chmod permission, chmod 777, read, write, execute, user, others and group. So for process, we are having various system call like fork. Fork is used to create a process. From one process, using one fork command, it is going to create two child processes. So using one fork command, we can create two child. Like I'm having this process, and if I can apply the fork, so this process will create two child processes. One is this and the other is this, like this. So exit, for exiting process, the exit system call. For waiting of the process, we need a wait system call. For file, we are having open file, read file, write file, close file. So these are the various system calls we are using for the various purpose and communication between the user mode and the kernel mode. Thank you very much for today's session.